Have you ever been challenged to hit the crossbar with a soccer ball before? Well, I have, and I have been wondering how fast and at what angle does the ball need to be kicked at so the ball hits the crossbar at the ball's max height. As you can see here, we are given the distance in the X and Y direction that the ball is away from the crossbar. So with an angled projectile problem like this, we will need to use the following equations. First, we need to find the initial velocity in the Y direction. To find the initial velocity in the Y direction, we will use the equation velocity final squared equals velocity initial squared plus 2 times a times delta y, which means distance or change in the Y direction. Here we have our equation set up and our model of the problem and what we are going to be solving for. Next, I like to write in our variables off to the side so I know where my numbers are coming from. Now we will plug in our numbers for the equation and solve. So, velocity final squared equals 0, because final velocity is 0, equals velocity initial squared, which is what we were looking for, so we keep that in the problem, plus 2 times acceleration, which is negative 9.81, times delta y, which is 2.4. Those three numbers multiplied together equals negative 47.088. Then we are left with 0 equals velocity initial squared plus negative 47.088. We need to get the velocity initial squared by itself, so we move negative 47.088 to the other side, which makes it become positive. Then we take the square root of 47.088 and we get 6.86 equals velocity initial. Now that we know our initial velocity in the Y direction, we need an equation to find the time it takes for the ball to travel said distance at said velocity. To find time, we will use the equation velocity final equals velocity initial plus acceleration times time. Here we have our equation set up and our model of the problem and what we are going to be solving for. Next, I like to write in our variables off to the side so I know where my numbers are coming from. We're going to plug in our numbers into the equation. So, velocity final equals 0, velocity initial equals 6.86, plus acceleration, which is negative 9.81, times time, which we don't know, so it's just t. Next, we need to get t alone, so we are going to move negative 9.81 times t to the other side, and then we will divide both sides by 9.81, which gives us an answer. Our answer comes out to be t equals 0.7 seconds. Now that we have found time, we need to find the velocity initial in the x direction. To find velocity initial in the x direction, we use velocity equals delta x divided by time. Here we have our equation set up, and then here we are plugging in our variables off to the side so we know where we got our variables from. Now we're going to plug in our variables into our equation. So VIX, because that's what we're looking for, delta x, we'll plug in 16.54, and then divided by time, and our time is 0.7 seconds. Then, in our calculator, we will take 16.5 divided by 0.7 seconds, which gets you 23.6, which is your V initial in the x direction. Now that we've solved for our other variables, we need to solve for our angle at which the ball is being kicked at, which is theta. When solving for theta, we do not use a kinematic equation because theta likes to be special. Instead, we're going to take the opposite of theta over the adjacent side of theta, which means tan of theta equals opposite over adjacent. Then we have to get theta by itself. So we have theta equals inverse tangent of opposite over adjacent side. Then in our calculator, we'll plug in inverse tangent 6.86 divided by 23.6. And our answer for theta will be 16.2. Now that we know all our variables and the answers to our equations, we are able to hit the crossbar.
It hit it! It hit it! Oh. Oh, I thought that was...